So, you're multiplying here. You can't cancel, so now you're going to apply all your lovely factoring rules. So when you look at x squared minus 16, what screams at you? I'm a, which one of those? Two terms. Yeah. X is squared, 16. We know 16 is 4 squared, so this is perfect squares. Easiest one to factor. You know it's going to be two binomials. What's going to be in it? Yeah. X plus. Yeah. You're going to do the conjugates. The middle terms cancel. It's going to come out lovely. You like those. Okay, what about the bottom of that one? Thinking you see an x cubed. So it's got to be a cube, but is 64 a cube number? Yes. 64 is 4 cubed. You have to realize that. So when you go to factor it, yes, we're using the perfect cube rule with pluses here, but what do I put in the first parenthesis then when I'm supposed to uncube it? X, keep the same sign, so it's plus 4. Okay, that's the key, because once you get that one done, then the trinomial is pretty easy. To do the trinomial, you just go, okay, square the first thing I wrote, x squared, plus or minus. Switch the sign, multiply the two things you wrote right there. Square the last thing you wrote, 16. That trinomial won't go farther, so you don't need to try. We're halfway there. All right? Now you're looking at a three-term expression, but what do you notice about that three-term expression? There's something. This has an x in every term, doesn't it? So this got an x in every term doesn't mean you can take out. You can take an x out. So look for common factors. I can take an x out of every term there. And then that looks a whole lot less intimidating if I take an x out. In fact, do I need to factor it farther? It's going to cancel with that one. So, hey, it's fine. We're going to ditch it in a moment. Actually, it won't factor farther anyhow. If you try, you won't get the numbers to work. Okay, so last but not least, little old measly 4 minus x. Does it look like there's anything I can do to it? Yeah. Why do you want to take the negative out of it? Yeah. Everything else has the x's first. You don't want that backwards. So yes, pull the negative out, which will make it become x, and the 4 will become minus. So you're going to use that trick a lot. Then it's the fun part. Cancel your little hearts out. What goes? Yeah, plus 4s go, okay? That's minus 4s. Yeah, the big trinomials go. Technically, you're left with x over negative 1. It's not a great way to write that. It's just negative x. Bring it up. It's over 1. Don't need to do that. So, yeah. Now, you got to admit, that's cool. You took that big messy thing and get negative x. It's cool. You're just like, whoa, yeah, I got rid of all that junk. It's fascinating that it works. You got to appreciate the beauty of it. You're not giving me faces that are appreciating the beauty. It is. It's cool. Well, I don't know if I go masterpiece. There's some math that's a masterpiece, but this is a beautiful little side piece of artwork here. Okay, so do we think we have multiplication and division basic idea? You factor, you cancel. Lots of canceling. Okay, so let's do everybody's favorite. Let's add and subtract. You'll love it. And so I must take you back to the basics. How do you add 3/4 plus 7/10? You have to make common denominators. Okay, you all just look at, boom, 20. You all know your numbers so well now, you can just look at and spot the least common denominator. But why not 40? it's gonna be a bigger number. I'm gonna have to reduce it at the end. It's a guaranteed way to make a common denominator if you just multiply the two denominators you've got, but it's gonna make you have lots of extra work. And in the case of doing this with variables, it's gonna make your life a nightmare if you don't have the least common denominator. It's gonna make the algebra horrible if you've got too big of a common denominator. You want to get it down. The question is, okay, mathematically, does anybody remember back in the good old days, probably, I don't know, 5th, 6th grade? How would you figure, before you guys just had instant number and you just knew, how would you have figured out that was a 20 as a common denominator? Yes, this is when you made factor trees. Remember factor trees? Okay, well, I'm not going to make you just right now I'm going to do a factor tree, but beyond that, we're going to get the concept. Okay, so you would break 4 down into a factor tree of 2 and 2. And you would break 10 down into factors of 2 and 5. Okay, so here's the question. I had a hard time getting this across last block. When you go to make the common denominator then, how do you figure out how many 2's should you keep in that common denominator? Because I see 1, 2, 3 here. Should I keep all 3? No. It's the largest amount that was in one of the fractions. This one had 2 in it. This one only has 1 of them. So you would keep 2 of them. And then you go 5s. What's the largest amount of 5s I see in one fraction? There's 1. And golly gee, if you multiplied that, wouldn't you get 20? So, okay, that's the process. Okay, why do I care? Because I'm going to may give you something like this. 2 over x squared y plus 3 over xy cubed. And I'm going to say add those. How are you going to figure out what the common denominator is? You're going to look at it and go, what's the largest number of x's I see in one fraction? X squared. Okay, what's the largest number of y's you see in one fraction? Cubed. That's your common denominator. Okay, and so I would, of course, have to do that for each one. All right, we'll come back to that in a second. Now, how do you change 3/4 into 20ths? Yeah, you went, oh, I'd have to times this by 5, and of course I have to do, if I do it to the bottom, I have to do it to the top, and you get an incredibly difficult 15/20ths. When you change the other one, what do? 10 would have to get times by 2 to make 20ths. And so if I multiply the top times 2, I would have 14. And then last but not least, what do you add? You only add the numerators. You don't change the common denominator. So it will stay 20. And on top I'll have 29. And we don't go to mixed fractions. We like improper fractions. That's just hunky-dory the way it is. Okay, so now, deal with the variables. Look at what you have in this fraction and go, what do I need to multiply by to make it have this common denominator we picked out? What's it missing? It's got the x squared, but yeah, it's only got 1 y. It needs 2 more y's, so you'll multiply it by y squared. Top and bottom, which will give you 2y squared then. Okay. The second fraction, what's it missing? It needs, because it's single x, because it's got 1, it needs another one. So I'll times the top by the same thing, and that will give me 3x. Okay, then you add it together. Now, you're only adding the numerators. You hope you have some common like terms that you can add together. In this case, are they like terms? 2y squared and 3x. They don't combine. So you would just leave this one as 2y squared plus 3x and put it all over the common denominator. And you added your fractions together. Boy, howdy, was that good fun. Come on, guys, we're having great fun here. It's fractions, but yeah, it's a little messy. It can get a lot messy, but not horrible. Okay. I got time to do 2 problems. We're good. Go, dude. Actually, I think let's just new screen this one. All right, so it's time for some fun now. Whoa, that was kind of funky. And we are going to, I got to remember how this worked. That's a plus. X plus 2 over 9 minus x squared. Oh well, it's happy. It'll be fine down there. Okay, so here's where you can make your lives miserable or you can make your lives tolerable. Do you just go, oh look, each of these has 2 totally different denominators. They're not alike, so I should just use each one of those in my common denominator, and that's the common denominator. Trinomial times binomial, there's a common denominator. If you do that, you will have an algebraic nightmare on top like no other, and you will cry. Okay? We prefer not to have crying, sends bad messages. Okay. If you are doing one of these particularly, it'll be on addition and subtraction. If you have a problem that is so messy and you're having to multiply out bazillions of terms, your common denominator is wrong. I have not given you anything that will be some algebraic nightmare. I will not have done that to you. So if you've got something horrible, something's wrong. What you need to do before you can decide on the common denominator, will either of those denominators factor? Yes. Yeah, you need to get them down to factors. You sort of like make your factor tree. So this is a trinomial, so it should factor down. It's pretty easy factoring. What is it? Plus 3 and plus 3. 3x and 3x will make 6x in the middle. We're good. So that wasn't bad. Ignore that now. Okay. Does anything bug you about this one? It's backwards again, because don't you really want x squared first minus a number? So how am I going to flip it? Take a negative out, it'll go backwards, x squared minus 9. Okay. You don't have to do this right now, but I'm going to tell you to do it right now, because otherwise we have this tendency to lose it. Negatives are a pain. They are your number one nemesis. They're like the evil Darth Vader coming after you. Okay? You do not want a negative in your common denominator. That is a royal pain. That will cause you issues. We have to prove a point. Is there a difference between this fraction, and this fraction? Aren't they all numerically the same value? So therefore, when you're working with fractions, you get to pick where you put the negative. You can put it on the top, you can put it on the bottom, you can put it out front. It doesn't matter. You get to pick. So you're looking at this fraction we just did. We pulled out this negative. You're going, I don't want a negative in the denominator. I get to pick where I want to put it. You have 2 choices. You can either change the plus sign out here in the middle to a minus, or you can take it to the top of the fraction and just change all the signs on the top of the fraction. Which one strikes you at the moment? Change the addition subtraction? In this particular case, I probably would do that. So that's going to become a plus. This is now a minus. Just move the negative out of your way. Okay. Thank you. So then, yes, won't this dude now factor? That's now x plus 3 and x minus 3. Okay, it's done. Then decide on what's my common denominator. And it's the same old thing. How many what's the largest amount of x plus 3's you see in one problem? This one has 2. This one has 1. So how many go in your common denominator? 2. Okay. They'll write it, instead of writing it out twice, they'll write it as x plus 3 squared. If you want to write it out twice, that's fine, but they're going to just write it as 2. Okay. Are there any other terms I need in my common denominator? I see 1 x minus 3, so therefore I have to have one of those as well. I'm going to have x plus 3 squared and x minus 3. And then Now you go back, that's the common denominator, you go back and you ask yourself, what is the first fraction missing? What does it not have in our common denominator? It's missing x minus 3, so it's going to get multiplied by x minus 3. Okay, here's the good news. What do I have to do to multiply the top? Foil. You're going to foil your little hearts out. So, yeah, 2x squared, outsides are x, insides are negative 6x, last are negative 3. Fraction 1 done. Okay, fraction 2. Ooh, what did I just do wrong? Where's my error? That's supposed to be a subtraction sign. I looked up there and saw the plus and didn't even copy the subtraction. So that is a minus at the moment. What is this fraction missing in the common denominator? Yeah, it's supposed to have 2x plus 3, so it needs an x plus 3. And so I will get to FOIL that baby then, which will be x squared plus 3x plus 2x plus 6. Now what? I need to add the numerators. Well, actually, in this case, I need to subtract the numerators. Okay. Here is where I would recommend a change. If you're subtracting, it means you're subtracting every single term you see here, not just the first one. I see people mess this up all the time. So I'm going to tell you, if you have a subtraction out there, I highly recommend before you actually start combining terms that you go through there, you make this a plus, and you go through there and you change every single sign, or it's just so easy to forget it, and then it doesn't count right. Okay. Now combine like terms. I would work from highest power to lowest. So x squared, so what do I get when I combine x squared? 2x squared minus 1x squared is 1x squared. Okay, x's. 1 minus 6, negative 5. Minus 3 more would be negative 8. Minus 2 would be negative 10. Okay, and then constant numbers. Negative 3 and negative 6 would be negative 9. That's not bad. It's pretty tolerable. The common denominator does not change, so you just copy it down. More than likely, you're done. But once in a while, you get lucky, and so you at least need to stop and ask yourself, could I factor that top and cancel it with anything on the bottom? And when I mean truly cancel it, to only cancel with something on the bottom, I have to be able to factor this thing and get something that had 3's in it. Is there any way this is going to factor using 3's and get me a 10 in the middle? No, this one's not going to break. It might factor, but if it's not going to cancel with the bottom, we don't care. You only want to factor it if you can cancel it. Yeah, if you do go ahead and factor, that's fine. You never multiply the denominator together. You will not FOIL the denominator. You just leave it as factors the whole time. So that would be as simple as we could take that one. Boy, howdy. Think of it. How much paper are y'all using up? Yeah.